Hello guys, how's it going? This is Mike coming back at you with another video on Foundations of Math 2. In the previous video, we continued our discussion on sets. We talked about the universal set, which other sets live in, and we talked about some special sets that we can get given to sets A and B. The union, the difference, the intersection, and then the complement of a set as well. In this video, we are going to talk about a nice visual way to look at sets and those special relationships between those sets with Venn diagrams. These things you've probably seen at the very least, if not worked with in some of your previous math classes, but we'll spend a little bit of time working with them and going over them as well. So, what we did in the previous video, just given some sets and the elements, and then having to come up with the union or the intersection, things like that. Sometimes it's not the nicest, it's not the easiest way to see what's actually going on. And then when we get into some general properties of sets, things can get kind of complicated. And when you see some facts about when two sets are equal, it may be confusing as to why those things are indeed equal. So this is where Venn diagrams come in, and we sketch those circles that overlap at some point. This can really give us a nice visual as to sort of proving that two sets are equivalent. Really there's going to be two different kinds of Venn diagrams that we're going to be working with in this video. We could have two sets, A and B, that would be symbolized by the Venn diagram on your left. And then we could also have three sets involved, A, B, and C, that's symbolized by the Venn diagram on your right. So let's just get right into getting a visual representation of some sets by using Venn diagrams. So here we have two sets, A and B, inside of a universal set U. And we want to get the visual for A intersect B prime, or A intersect B complement. So what you want to do, just in general, when you're getting a visual for these kinds of sets, highlight what composes each of the components in your statement here. So I am going to highlight or mark what is A, and I'm going to highlight or mark what is part of B complement, and then wherever those two things overlap, that is going to be, in this case, the intersection of those two things. A intersects B complement. If I was talking about A union B complement, then it would be wherever one of those things is, then that would be what we are looking for. But as I said, in this case, we are doing the intersection, so let's figure out what's what individually, and then where things overlap, that's what we are looking for. So the first thing is just A. So everything that's in the circle for A, that'd be this thing right here, I'm just going to highlight with some diagonal lines here going this way. And you can shade it in however you want. There's no one particular right way that you have to shade it. Next, I'm also going to highlight B complement. This is everything that's in U that is not in our set B. So everything in this rectangle that lies outside of that circle. And I'm going to do this a different way so we can clearly tell the difference. there's our very rough highlighting as far as what is in the complement of B. So now, again, we had A intersect B complement. So wherever these highlights or these diagonal lines are overlapping, that is where we are going to have the set we are looking for. That's where we're going to have the intersection of A and B complement. And if we take a look on our Venn diagram here, everything that's inside of the moving dot, which I'm outlining here, that's where we have the diagonal lines overlapping. So I'm going to just, in red, signify that this is A intersect B complement there. So there we go. That's how we can figure out what a particular set is using Venn diagrams. Based on the sets A and B we were given, maybe we could do this if there weren't too many elements. It might not be so bad, but based on what your sets A and B are, it could be kind of nasty. So this is definitely a nicer way to visualize some tolerable yet not very nice sets here. We'll go on to another sample here. This one contains 3 sets A, B, and C. And here we want to sketch out what is A union B intersect C. So I am going to first figure out what is A union B. What are all the things that are in either A or B? Well, if you look at our circles, sorry, this is A, that's B. Everything in this almost 8-shaped kind of thing there, that is going to be A union B. So I'm just going to draw some diagonal lines to represent that. So that is A union B. Now I have C, and what I want to find is, again, the intersection of these 2 things. So I'm going to draw some other lines to represent everything that's in this circle C here. So I'll go horizontal. If it helps you personally more, you can actually shade in the entire circle on your paper. And now again, we are doing the intersection here, so we just want to figure out where are these things overlapping. And that's going to be everything in here. Shade in how you will. I am not an art major. I do not claim any of my drawings to be masterpieces. So however you choose to shade in, you choose to shade in. But there, what we have highlighted in green, that right there is going to be the intersection of A union B and C, because that's where the red lines overlapped with each other. Let's do one more here with the triple Venn diagram with A, B, and C. and let's do a union here. Let's do A union B intersects C. So let's see what this is going to look like with a little bit of a visual here. If you have parentheses involved in the set that you're trying to visualize, typically do that thing first. So B intersects C. I need all the things that are in B and C at the same time. B is that circle there. C is this circle here. So this football-shaped area, that's going to be my intersection. So draw some lines there just to represent that. And then I also have my set A. And I'm just going to use some other diagonal lines going the opposite way to represent this set A. All right, so we have A, we have B intersect C. We're taking the union of these things now. So unlike the previous two samples where we wanted the things that were in both sets, since we're doing the union now, we only care about the things as long as they're in at least one of the sets. So in this case, anywhere we see a green line, we are going to include that in our set here that we have listed at the right. So just lightly shading this, everything that's in black this is all going to be part of A union B intersects C. So this is just one more sample here, just to sort of help us visualize an arbitrary type of set here that you could be asked to find. The next two examples I want to do actually signify a particular property that is true of any two sets, A and B. I have A union B, and I want to look at the complement of that guy. Let's see, what is this thing going to equal? I want to know, I want to get a visual and see what these things are going to equal. Okay, so A union B is everything that's inside of at least one of these two circles. So the complement is everything outside of one of those two circles. So basically, it's everything that I have dashed here in black. All this here is the complement of A union B. I want to see if I can come up with two other sets that will, such that when I take some kind of combination of them, either the union or the intersection or something like that, I can come up with the same set of stuff. I can come up with exactly what is dashed in black there. Well, everything that is dashed there in black lies outside of the sets A and B. My apologies. So knowing that everything lies outside of those sets, that sort of hints that the complements are going to have to be involved somehow. And if if I do a little bit of trial and error with this, if I look at a complement, everything outside of this circle here, that's going to certainly include everything in black, but it's also going to include everything that is in this part of B here. So that's some extra stuff that we have that we don't want. If I look at B complement, that gives me everything that's dashed in black, but then it also gives me this stuff here. Everything that's in this portion of A. And again, that's extra stuff that we don't want. But notice that these two chunks in blue here, these two areas in blue, do not intersect each other. So if I can just remove the two sets of, or the two pieces of area that don't overlap, then I can get what it is I want. And how we do that is we take the intersection. So we want A complement intersects B complement. And if you, on your own piece of paper, if you sketch this same thing, if you sketch a Venn diagram with two circles and a rectangle, if you sketch or highlight A complement and you highlight B complement and you take the intersection of those things, you are then going to get exactly what we have in black here. You're going to come up with exactly the same set of stuff. So, A union B complement is equal to A complement intersect B complement. And this is one part of a two-part theorem or fact, which is known as De Morgan's laws. De Morgan was a famous mathematician a few hundred years back. So he has some properties of logic and sets named after him. So this is one of the two pieces. The other piece of it, very similar. This is A intersect B complement equals A complement union B complement. And I'm going to challenge you to try to see this on your own. Try to sketch out what is A intersect B complement, and then do A complement union B complement. Maybe you have to do these in two separate Venn diagrams. Maybe you can do it in one, but just try to figure this out on your own and see that you come up with exactly the same set of stuff. So press pause, try this on your own. When you think you have two Venn diagrams that are the same, press play, and I'll show you a little bit of a visual of it on here. All right, so let's get a little bit of a visual of these things here. So first, I'm going to sketch out the complement of A intersect B. A intersect B is this thing right here, so I'm going to highlight everything that's outside of that. There's going to be a lot of stuff to sketch out here. again, we're not going very technical with these drawings. You will not be graded based on your capabilities of sketching and or any kind of artwork. So this is the complement of A intersect B. There we go. So now let's see how A complement union B complement gives us all that same stuff. So for A complement, I'm going to do this in a dark green. Everything outside of this circle A. All that's highlighted or dashed in green there. And now for the representation of B complement, I'm going to go the same direction, but I'm going to do it in red here. So I'm going to have So, if we take a look at this Venn diagram, we see that wherever there is at least one of green or red, at least one of those two things happening, that is the union that we are looking at here. At least where you have one of green or red happening, that's also where you have blue happening. Blue was the complement of the intersection. Green and or red was the union of the complements. So this is just a visual representation of the other part of De Morgan's laws. There are several other properties as far as sets go out there. We'll spend a little bit of time on them later on, but not too much. For the most part, basic things like complements, intersections, all that stuff. These are the kinds of things that we are going to be focusing on here. We're not going to get too deep into this. We're not going to do too many complicated samples here. In the next video, we are going to look at some word problems, and we're going to see how we can use Venn diagrams to solve word problems. If you have any questions or comments, please be sure to reach out to me. Send me an email. Send me a text. Send me a message using Morse code. Send me something in Braille, whatever you have to do. Otherwise, until the next video, take it easy, guys.